And we're almost live. Okay, can you hear me?
Yes.
Uh, Okay, all I have to do is figure out if I am recording. Am I recording? I am recording. And am I sharing screen? Yes. Okay. So, all right. So listen, I hurt my back, so I'm having a hard time driving and going places, and I don't want to sit here too long. But I will. The last class I thought I was going to get out early and I didn't. So I'm going to try to get out as quick as I can. But the only reason I'm doing this at all, instead of just taking a day to rest, is because you have a test on Friday. So I need to make sure that I go over everything. So let's talk about it. Let's start off with homework for. Okay, so where is that? Okay. Mm, This is not you. This is you. Let's take a look at mod 4, quiz 4. Right? Um, okay, so let's start with this one. Look at lines 8 and 9 and tell me what happens. So what happens in lines 8 and 9? Anyone know what that is? What did they do between lines 8 and line 9? Looks exactly the same except what? What happened?
They're taking the derivative?
Yeah, they took the derivative. Thank you, Aiden. So let's see what choices they have for taking the derivative. Use the power and chain rule to find the derivative. Nope, none of that was done. The derivative was certainly not taken 4 times. Use the given position function to find your acceleration. I don't see position function is usually S. Product rule, Newton's method, implicit differentiation. Okay, so the only one, it's not the product rule. Newton's method is used to do what? To find anyone? It's used to find zeros. Okay. And then implicit differentiation is the only thing. So that's all it was. They just took the derivative of everything. There's a y in here and it's not explicit, so it's implicit. So they just took the derivative. Okay. Any questions on that? Okay. Next one. Okay. So listen, on the test, there's going to be a lot more talking and a lot less writing. Okay, so when you're given a problem like this, and it says sunflowers are being grown on a space station, determine the period A, and in the 20th week, how old, tall are they, how fast are they growing and accelerating? So I'm going to expect, I'm going to actually change on the test, it'll say that I want you to speak this, to present it. So anyway, time, height, what did they say, 20th week? 20th week. So you go down here and you put in 20 for the 20th week. Okay. And then if you turn it on, one of the things it's going to ask you is the period. looks to me like the period from here to where it repeats there again is 20. So the period isn't 10, but 20. So in the 20th week, the height is 1 centimeter. They said use whole numbers. So it's 1 centimeter and it's growing at 10 centimeters per week. And it's accelerating at 10 centimeters per week. Okay. So according to the sine regression, to determine the period, which is 20, and then the 20th week, how tall are they? They're 1 centimeter and they're growing at 10 centimeters per second and they're accelerating at 10 centimeters per second per week. Sorry. Okay. All right. Any questions on that? Find the derivative of cosh squared of 3x. Okay, so I'm going to just take this to the decimal sheet because this is one you have to do. Okay, just remember that that's actually I'm going to take it out this. I'm going to write it as this cosh squared. And I want the derivative. Okay, so what I would do is in taking the derivative, I would do a power. So I would bring the 2 down, subtract 1 from it. A 2 from the, oh, so I subtract 1 from the power. What rule am I using to do that? Anyone? What rule am I doing here?
Power rule?
Thank you, Alicia. It is the power rule. But now I have to multiply it by the derivative of the inside. Just this. Okay. And if I change the color, let me change the color to purple. Okay, you see that's the same answer. The purple and the red line are the same. Okay, so we didn't change anything. Okay, by the way, where did that derivative of cosh of 3x come from? What rule is that? Anyone?
Chain
Okay.
rule?
Chain rule, very good. Thank you, Aiden. All right, so I'll put this here. The derivative of cosh is what? Anyone?
Sine, negative sine h.
Don't say sine h. Hyperbolic sine or sinh. Okay? And then I leave the inside alone. And you see, that's not the answer. If I look, the blue line and the purple line are different. Because what do I have to do? I took the derivative of cosh and I got sinh. I left the inside alone, and then what do I have to do? Multiply it by what? Aiden, what was the chain rule? What did it say to do? Multiply it by
3.
yes, or the derivative dx of the 3x. So this is the chain rule twice. Now you see they're the same. The blue and the purple are the same line. Okay. So let's just clean this up a bit. So I don't need these parentheses at all. And I don't need that power. And the derivative of 3x is just 3. So I'll put that there with the 2 and make that 6. Okay, so that must be the answer. 6 cosh 3x, sinh of 3x. 6 cosh of 3x, sinh of 3x. Okay, that was the question 4. So that was one you had to do. Okay, here's another one you have to do. Newton's method. Okay. So for Newton's method, I'm going to create a function. Okay. Remembering to raise that to the third power, raise to the third. Okay. So there, let me turn all these off because I don't need any of those. Boop. So there's my function. And what am I trying to do in Newton's method? Newton's method is, by the way, this first formula right here. What am I trying to do?
Find the zeros. Find my intercepts
Yes.
here.
So where do you think that zero is? Around where? Anybody? Where's the zero of this function? Zero is the x-intercept. Where's the x-intercept of this graph?
It's 5. And it's at 5, when it's on 5.
That would be the y-intercept.
That would be around the 2 somewhere.
-2 somewhere. Here it is, minus 2.0, whatever. So I'll take that. And I'll put it into Newton's method. Now all I did was create a formula, so I could just type it in this way. There. Then you see that number didn't change any. 2.0, it's 2.094552, 2.094551. Okay, 1/4. So let me just try 1 and 4. As long as these numbers don't change, we're done. So the answer we want is going to be 6 of these, so it'll be that. So that's the answer that we want to put in. It'll end in 4551. Yep, 4551. That's another one that you might have to do, a Newton's method. It's perfectly easy enough to do. This is another Newton's method. I'm not going to do another Newton's method. Okay, so for this one, it says, say your prediction, period of 5 weeks. So the 5th week. So let's see. So we go in here and we're talking about the 5th week. And if you want the period, how do I get the period for this? Who was paying attention and wants to tell me how I got the period?
You should graph it.
Okay, which I do by turning that on. So what do you think the period is?
It's around around 6. No, I mean 20.
20. Yeah, it's the same graph we had before, so it's 20. Okay, so according to the sine regression with a period of 20, in the 5th week, the plants are 100, sunflowers are 130 centimeters high, 131 centimeters high, and they're growing by 31 centimeters per week, and they're decelerating by 3 centimeters per week Okay, so there's the 20 minus 3, 31, 131. Okay. Any questions on that? Or in this test, I'm gonna improve. I have to change these instructions because I want you to be sure to say it out loud. So you can put these numbers in for your own reference, but I need to hear them. Okay, I will be listening. Same question, different week. Okay, this is another one I'll be listening to. So can anyone want to read that out loud for me? Not Eric. He just answered. And not Aiden, because he just answered. How about Sebastian? Can you read this? Haven't heard from you yet. Hello? Are you there?
Yep, sorry, my Zoom is being weird.
Oh, I'm told if you hit the space bar, it'll mute or unmute, but it doesn't seem to work that way for me. Just does that.
Hmm.
Okay, so what does this say?
Uh, so you don't like us saying parenthesis, right? Or
No, don't say, well, no.
it's a starting statement 10 H.
No, not tan H. What does the H mean?
I don't remember.
Hyperbolic.
Oh, hyperbolic of tan, uh, opening statement X, closing statement.
No, don't even have to say that. You could say
Okay.
hyperbolic tangent of X, or you could
Oh,
just say hyperbolic tangent. What's the little prime mean? See the little dash at the end? What does that mean?
I don't remember.
Oh, that one you need to remember. But anyone, what does this little dash mean at the end here? What? That's not a fancy thing. That's one we've been doing all along. What does
It's prime, right?
Yes, it's prime or the derivative. So you could say the derivative of hyperbolic tangent, or you could say hyperbolic tangent prime equals. You want to take a stab at this one?
Sure. Hyperbolic secant squared of X
That's great. Now the
plus
last,
G to the power of 4. Uh, opening statement 0, closing statement.
okay. So that means evaluated at 0, but that 4, it's not to the fourth power. That's a mistake everyone's going to make, or let's put it this way. That's the mistake that's made most in these sorts of problems. What does it mean when I say to the fourth power? Not to the fourth power. When I put the fourth power in parentheses like that, it's not to the fourth. And if you look at these, you'll see most of them are giving you hints as to what it is. Do you see what it says? The fourth what?
Derivative.
Yeah, it's the fourth derivative of g evaluated at 0. So it's the derivative of the hyperbolic tangent is equal to the hyperbolic secant squared plus the fourth derivative of g evaluated at 0. Okay. All right. I don't know how many more of these we need to do. That's it. That was the last one. Okay. Any questions on that? Let me close these up while I'm. Nope. Don't need that. All right. Yeah. I'll leave that there for now. Here's my. Here it is. Okay, so put that over there. And so that was homework. So what about the group work? Take it back, open it up. Let's take a look at the group work and see what you did. So you have group work today of module 4 group work is on transcendental derivatives, which means you have the side. Okay, we got 4 groups. So let's try Slade's group first. Okay, let me see what Garv is saying. Okay. All right. So, but nobody said what that was nice, sounded smart. perfectly fine. But nobody said what Selena said. Selena, can you say what you said? Are you here? Oh, Selena's problems. Garv, you want to say what she said here? Just read it out loud.
Yeah, according to the sign regression with a period of 320 and a salary of $75,000, we have between 2 or 3 BFFs. And as the salary increases, the amount of BFF decreases to approximately 1 BFFs.
Okay, so no, that may be true, but don't say that's not what this says. So Selena, you have to say it this way. It's wait, $75,000. You can say you have between 2 and 3. That makes sense between 2, but it's not going down to 1 BFF. You don't know that. In fact, it's at this rate, it's not going down to 1 anytime soon. You're losing 300ths of a BFF per $1,000. So if you make $76,000, you will lose 300ths of a BFF. That's like a finger on a person's body. Okay, so you're basically not losing any BFFs. So what you want to say, Selena, is that, and it's not this, as the salary increases, the amount of BFFs remains about the same. And the second derivative being 7.4 times 10 to the negative fourth, that's 7 10,000ths. That's also about the same. And then you should say, and it's not accelerating or decelerating. When it's close to 0, it's not accelerating or decelerating. Okay? All right. Let's try the next one, see if that one's different. Alicia, she's talking about, what are you talking about, Alicia? World population. Let's see what Pavani says. Okay, 2 problems with this. One is speak louder. The second thing is so Luke has a mistake here. It's not decreasing. It's increasing. You can't say it's increasing and then decreasing. It's increasing and decelerating. Okay. And then don't say negative when you're talking, and you don't have to give all these decimal places either. If you're speaking to your mother, you don't have to say 4.29 million people per million. You could just say 4 million people per year. Okay. Got that, Luke? Is Luke here?
Yeah, got it.
Okay, great. There we go. This one was okay, though. World population group. Good. All right, next group. Sebastian's group is doing drugs. And nobody's speaking it. So Aiden, could you read yours out loud since you're here?
According to the sign regression with a period of 16, at month 2, the drug potency is 103 micrograms per cc, and the drug potency is accelerating by 1.8 micrograms per cc per month, and the drug potency is also accelerating by 0.3 micrograms per cc per month.
Beautiful. Wonderful. Okay, next one. Acacia. Acacia is here. What are you talking about? Your hour studying and your grades. Okay. And Jonathan, you have to read it because nobody's here.
Oh, excuse me. According to the sign regression, after 12 hours of studying, we would have achieved a grade of approximately 72%. This would be increasing by approximately 5.2% per hour and decelerating approximately 0.3% per hour.
Beautiful. Perfect. Okay. I think that's it. All right. What else do we got here? Let me just put that away again. So that's our group work stuff. All right, class questions. Let's pull this back again. Go to Hold on. Mm. Class question. Okay, so let me just talk about the test for a second. So listen, I think I told you this already. The test is going to start off with vocabulary words, where I'm going to be asking you questions like I've been asking on quizzes. What you're going to do is you're going to answer them as quickly as possible. If you take too long to answer the question, you're going to lose points. So you can lose points not just for being wrong, but for taking too long. Okay, so I know you probably didn't see that I posted these because I posted them pretty late. So let me just show you who you are, and then you could give you a moment to find your question. Okay, is that everybody? So here, so now you know which question I'm going to ask you. And I'll just also say about the test that the test will start off with these questions, but I like to ask three vocabulary questions. They're usually I wouldn't say they're pretty easy, but the first one is usually one of the easier ones, like what is math? What is calculus? What is pre-calculus? So what is math? Math is a language. What is calculus? It's the study of change. What's changing? Functions. Okay, from pre-calculus. And then I might ask, what are the two rates of change, average and instantaneous? And then Slade, I know you're here.
Yeah.
How many points do we need for instantaneous rate of change?
1.
Okay, and average we needed 2, right? So Acacia, why did we invent limits? Do you remember? Acacia?
Yeah, sorry. It takes a while to unmute. To take the 2 points off average rate of change to the
1
the
point.
1 point of instantaneous rate of change.
Very good. All right, Justin, what do we need for continuity? Do you remember? Are you here? I don't think Justin's here, which is good because I don't really need this question answered. Okay. Cody. I didn't see Cody in a while. What are other ways of saying instantaneous rate of change? I don't see him, so. Eric, what's the derivative of okay, so what are the other ways of saying instantaneous rate of change? Derivative, slope of the tangent line, instantaneous rate of change, dy dx, velocity. Those are all ways of saying first derivative. Okay, Eric, it's the derivative of a constant.
It's 0, right?
It is. David, what's the derivative of x to the nth power? I don't see David, so. Okay. Aiden, that's a power rule. What does the product rule say, Aiden?
First times the derivative of the second plus the second times the derivative of the first.
Yes. Selena. Oh, Selena can't speak to us. There's no way you can speak to us at all? She said she couldn't. It's on the phone. It does unmute though. I'm sorry. Take the whole point off. Because you're here. Garv, what's the derivative of e to the x and the derivative of natural log of x?
The answer is d by dx times e to the power of x is equal to e to the power of x, d by dx, ln times x is equal to 1 by x.
Okay, so let's say it this way. The derivative of e to the x is e to the x. The derivative of natural log of x is 1 over x. Okay. If you wanted to add those d over dx things, you could say the derivative with respect to x. But honestly, I just want the derivative of e to the x is e to the x. I need you to remember those things.
Okay.
Rudra. Don't
Yes,
unmute.
sir.
What's the derivative of sine, cosine, and tangent?
So derivative of sine x equals to cos x. Derivative of cos x equals to negative sine x. Derivative of tan x equals to sec square x.
Secant squared.
Secant square.
Very good. All right. Sebastian, just the chain rules say.
It says that the derivative of the outside, leave the inside alone, then multiply by the derivative of the inside.
Great. Pamela's here. I didn't see Pamela. Pam, she is here. Hello, Pam. What's the relationship between position, velocity, and acceleration? Hello? I'm not hearing you. Hello? Okay, you're muted again. It seemed like you unmuted yourself for a second. What's the relationship between position, velocity, and acceleration? So, Luke, what is acceleration?
I have no clue.
All right, Pam, I'm skipping over you to Luke, and then he's going to help you. Listen, Pam, listen to what Luke says when I ask him. Luke, are you here? I know I saw you here. We
Yeah,
talked.
I'm here. The
Yeah, yeah.
acceleration is the second derivative.
Do you hear me, Pam? The acceleration is the second derivative. Okay, so what is the relationship between position, velocity, which I already said was something else, and acceleration, which is the second derivative? What's the relationship? What's missing? What's the velocity? So there's position, there's something, and then there's second derivative. So there's no derivatives, something, and two derivatives. What's the missing element? Pam, what's the relationship? What's the test called that you're going to be taking on Friday? It's not called test 1, it's called the something test. Okay. It's the derivatives test. The derivative relates them. The first derivative, position, is velocity. The second derivative is acceleration. Okay. Jonathan, what does the mean value theorem say?
I think this is the right one, but it says a derivative exists on AB so that it is equal to the arc on B.
Okay. That's the right answer, but you're just saying it wrong.
I figured. Can you help me out?
So yeah, when it says on AB, don't say it on AB, it's on the interval. So on the interval AB, or between A and B, or just simply say the average rate of change or the instantaneous rate of change is equal to the average rate of change. You
Okay,
need
thank you.
you need the interval for the average rate of change. The instantaneous rate of change is at a point, but you can't just say the average rate of change, or you can just say the average rate of change, but it's usually the average rate of change over some interval. Okay, so I just remember instantaneous rate of change equals average rate of change. We'll be working on that today. Okay, Pavani, what are the derivatives of? Okay, Pavani, are you here?
Yeah.
Could you read your question to me?
What is the derivative of sine h and cos h?
You want to fix that question? Say it again.
What is
Cos
the
H, yeah.
of sine h and cos h?
No, not sine H cos. Yes, that's what you're getting. How do you say that? Not sine H, not cosine H. You say them.
I
There's
forgot.
two ways of saying them. Anybody remember how to say them?
Hyperbolic sign.
Yes. Okay, so thank you. It's the hyperbolic sine or the hyperbolic cosine, or you could say sinh and cosh. But you don't say sine H, cosine H. You'll lose points for sure if you say that. Okay, so now, Pavani, can you read your question again and then answer it?
What is the derivative of sinh and cosh?
Okay, so what's the derivative of sinh? It's,
Cosh.
and what's the derivative of cosh? It's,
Sinh.
that's it. Very good. Alicia,
Yeah.
what do we do when we're trying to find y prime and it's in an equation, but not explicit?
We have to use implicit differentiation or like find the
uh,
derivative.
We take the derivative of the whole equation. Yes, very good. Hello.
Yes, sir. Newton's method finds series of equations.
Okay, very good. Thank you, Carlos. And Luke already answered his question, so we're good. Did I miss anybody? I think I got everybody. Yes. Yes. All right. Mm, mm, mm. Hold on a second. I have to make this smaller. So that, okay. What's the end of that? All right. So what are we doing today? So what I need to talk to you about, I really only expect to get to local linear approximations and related rates. So let me, oh, that wasn't good. Nope, that's not good either. Hold on. There we go. Yes. Okay, so we did everything that was due today. You can still do the quiz till midnight. Okay, local, linear, and related rates. So what are they? Okay, another word for local linear is called linearization because what you're doing is you're turning a function into a line. How are you turning a function into a line? Let me skip down to that part of this thing. Local linear approximation in mathematics, linearization is finding the linear approximation to a function at a given point. It's another word for find the equation of the tangent line at a point. The point is that point should be near where you want to, where you'll be working. Okay. So that it can be so you can evaluate the function by hand. Otherwise, there's no point in approximating. If you can't do it by hand, then if you have to, then you might as well just use Desmos and get the exact answer. But suppose you want to do the square root of 12. Okay, you can approximate it by finding the tangent line near the square root of 12. You would want the square root of 9 or the square root of 16. Those are ones you can get because they're perfect squares. Okay. So here's a picture. Actually, you know what I'm going to do is I'm going to switch over to Desmos. So in fresh Desmos. Hold on. Bloop. Okay, that's this one. Okay, so what I'm doing is I'm doing this one. Suppose I have a function g of x, the square root of x. That's this red one right here. Okay, and I want to find the square root of 12, which I can get, which is 3.46, blah, 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 but without the calculator. And you'll see why. Really, it's not the calculator so much. So what I'm going to do is I need to find the tangent line at a center near 12. So I'm going to use a center near 12, which will be, let's try now. Okay. So I'm going to write g of x as x to the 1/2 and g prime as 1/2 the square root x. That's the derivative. So then I have the line, that's the tangent line at any point A. Okay, so what I'm going to do is, first of all, I'm going to realize the derivative is 1/2 square root of A. And then the function is going to be the square root of A. So this is why I have to pick something I can make this. I need some number that I can find the square root of that's near 12. So the number that's near 12. Okay, let me just, a number that's near 12 would be 9. So we take this whole thing and I'm going to put 9s in there. So put a 9 in here, a 9 in here, and a 9 in here. Okay, so the square root of 9 is 3. So that's going to give me 1/6. That'll give me x minus 9. And then it'll give me the square root of 9 is plus 3. So that's this green line here. Okay, that is the local linear approximation of L of x equals. So that's our local linear approximation. Okay. All right. Are we good? So now I'm going to create a table. I'm just going to add a table so you can see this. There's a table. Okay, I'm going to pick some x values. Oops. X values. And then I'm going to do the square root of x. This will be the exact value. And then this will be our local linear approximation. Hold on. Kill these. Okay. Oh, there's one here. Okay, there we go. So there's our function. And then I'm going to add one more thing to this thing. I'm going to see what the difference is between the function and the local linear. Okay, so let's just take a look at this. If I plug in 9, for example, okay, let's take a look at the graph. You see at 9, I get the 0.93. So the square root of 9 is 3. That's the green one. Okay. Oh, that's not the green one. Let's turn these off. The local linear at 3, that one at 3, that's at 9 is also 3. So they're exactly the same right there at 9. Okay, they're so close you can't even see. They look like a line there. That's why it's called the local linear approximation, because in this area, they're both, yeah, they're kind of like a line. They're both the same. They fray a little at the edges, but they're mostly the same. And the difference is, I don't know why there's because it's f, not g. Hold on, g of x. The difference is 0. There's no difference. Now let's take a look at 10. The exact square root of 10 is 3.1627777. The local linear approximation is 3.1666666. And they're off by 4 thousandths. So they're really close. Okay, so at 10, when I'm here at 10, see, they're virtually the same. It's hard to get them to be, I can't even tell which is which. Okay, so then if I go to 11, you'll see they're starting to separate. I can see them better. This is the square root exactly, just 11 point. Looks like it's 11. Oh, no, it's 3.31, and this one is 3.31. They're really close. They're off by 1/100th. And you see, the further we go away, the further they get from each other. Okay. So now the square root of 16, we know the square root of 16 is 4, but our local linear is approximating it too big because the line is going up at 16. The square root of 16 is 4, but you see our local linear just keeps going up. It's getting bigger. You see, our local linear is following that green line. Square root is following the red line. And you see how they're separating from each other further and further? So if I want something like the square root of 400, square root of 400 I know is 20. Square root of 400, 20. But our local linear says this, it's 68. Okay, so obviously you have to stay local. You only get good answers when you stay local to whatever your A value is. Okay. All right, so if I wanted the square, so what if I use a different center? What if I use the center of, so here's why I put the 9s in. Let me put in 400s there. 400. 400. 400. Then if I look at my table, oh, this would be 2 times 20 would be 40. And then this would be 20. This would be 400. You'll see how far off I am. I'm off by chunks of numbers. For this, for 9, 10, and 11, these I'm off by a lot. Okay, but if I put in numbers that are close to 400, I get the exact 401. I'm off by a tiny amount, even something like 425. I'm not far off. Okay, so that's why you want to find a tangent line that's close to what you're looking for. Okay, and it has to be something you could take the square root of, otherwise you won't be able to get a line with numbers in it like that. Okay, that's not really what that may be an exam question. It's one of my favorite exam questions, like find the square root of 17 using a local linear approximation. Okay, but one of the things it is also used for something else. So I'm not that excited about this because if you want the square root of 17, you could just ask the square root of 17. There's the square root of 17. But what happens in chemistry sometimes is you have something like, you might have a formula where you have the sign of the concentration. Let me see, it's a bracket. You have something like this. And you have it in a formula. And you don't, chemists really hate doing stuff like this too, sign, whatever. But you know that that x is going to be small. So if you want to find the sign of x when x is small, okay, you just start off with the function, boop, f of x equals the sign of x. Okay, and then you use the center where a is 0. And so then you find the tangent line at x equals 0. So I'll need the derivative of 0. What's the derivative of sine? Well, the derivative, it does it right here, but if you wanted to know the derivative of sine, it's the cosine of x, so then it would be cosine of x. So that's the derivative. Okay, also, if you evaluate the sign at 0, the sign of 0 is 0. So when you do your local linear thing, so you're doing a linear approximation for the sign of x when x is close to 0. Okay, the derivative is 1, so replace that with a 1. The function is 0, so replace that with a 0. So this whole thing just becomes y equals x. Okay, so let's take a look at this for a second. There's a graph, oops. There's a graph of the sign of x. Do you see that the local linear, let me just do y equals x. This is the local linear. Do you see how around 0, they look very similar? Okay, the black line and the red line are the same. Okay, so the sign of x and the value of just 1x plus 0 are very similar. Okay, the difference is going to be super tiny. So in other words, in chemistry, when you see some formula, da 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 da, and you see the sign of x, that formula just becomes da 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 x. That's, if you can throw out transcendentals, that's great. And you can only do that because x is small. Okay. So those are the two good uses for local linear approximation. But honestly, approximating something as a line is not a bad idea, especially when they're so close. Look, they just look the same there. So no point in having to worry about the sign. Okay. All right. There's more notes in here if you want to look at them. Okay, next topic. Any other question? Any questions on that before I get started? Can I see a show of hands of people who are awake? Or you can talk to me. You can wait, hold on. You can either give me a thumbs up that you're still awake. Okay. I see some thumbs up, or you can turn your audio on. Okay. I see, I'm still missing some thumbs up. Pam, thumbs up? Oh, she turned her audio on for a second. Carlos, are you there?
Yes, I'm here.
Okay, good. Thank you all for thumbing up. All right, so we're going to go on to the next topic. It's a completely different topic. Okay. Oh, I see Selena tried to answer me on the text. Okay. So the problem is we're going to move on to the next subject, and the next subject is related rates. Okay. So what is a related rate? All right, what's this word that you need to know what a rate is? Remember, there was a special, when we said there's a word that you listen for. So remember what that word is that has to be in rates? Anyone? What's the word? Jonathan, what's the word? It's a three-letter word.
I'm sorry, can you repeat?
What's the word that we see in it that tells us that something's a rate?
Oh, per.
Per, that's it. So we're looking for the word per. Okay, so what we're looking at is when one rate affects another rate. Okay, so like in business, for example, if you're raising the price, that would be a rate. If you're raising the price over a period of time, that would be a rate. So if I raise the price by 2 cents a day, I'm raising that's a rate. Suppose the price is $10, but I'm raising it by 2 cents a day. Well, $10 is a value, 2 cents is the rate at which I'm increasing it by. Sales, what if at $10 I sell 100 items? Is that a rate or a value? 100 items. Do you hear the word per? So what is it? Is it a value or a rate? Anyone? Slade?
Sorry, what was the question again?
If I sell 100 items, is that a rate or a value?
A value.
Right. And if my sales are dropping by 10 per dollar, then what's that? Is that
A
a
rate.
rate? That's a rate. Okay, so obviously if I'm raising the price, if I'm raising the price over time, I'm lowering the sales. So one rate depends on another. All right, so how do we deal with related rates? You're going to start with the main formula. You're going to differentiate with respect to time, so you're going to get rates. And then you're going to identify all your rates and values, and then you're going to solve for whatever it is that's unknown. So that's the 4 steps we're going to use. Okay, when we take the derivative with respect to time, the rates will look something like dy dt, df dt, dr dt. Those will be instantaneous rates of change. Okay. The values will be stuff, will just be regular variables, td and r, whatever. All right, so remember, when you take the derivative, when you have something like x squared plus y squared equals z squared, or area equals length times width, or anytime, when you take the derivative with respect to t of y squared, the power rule says you get 2y. The chain rule says you get dy dt also. Okay, the powers that bring the 2 down, subtract 1. So remember, when you take the derivative of y squared, you'll get 2y dy dt. If you take the derivative of length times width, okay, it'll be a product rule. So it'll be the first times the derivative of the second plus the second times the derivative of the first. dw dt and dl dt are both rates. Okay, of time. All right. So let's start off. Let's do this one. This is one that frequently shows up on tests. Okay. They're telling you that the average yearly cost is this C bar. And then they give you a formula for it, and then I just write it this way so I can take the derivative of it. Okay, that's the main idea. That's the main idea given as a function. So when you take the derivative with respect to time, you're going to get derivative of c bar is going to be dc bar dt. Then you take the derivative of 14, you get 0, so that goes away. What's the derivative of 243x to the negative 1? Well, you're going to bring the negative 1 down, so it'll be minus 243x to the negative 2. What rule is that I just used? Again, what's the rule that I bring the
Power-
negative 1? The power rule.
Power rule.
Yep, thank you, Aiden. It's the power rule. And then where's does this dx dt come from? What's that? What rule is giving me that? Begins with a C. Rhymes with pain.
P.
Thank you, Josh. That's the chain rule. So I brought the negative 1 down, subtracted the power. But because I'm taking a derivative with respect to time, the variables don't match. This is t and that's x. So you're ending up with a dx dt. If you leave that out, that dx dt out, you'll discover that you have a value of x and you're looking for dc dt, but you have no place to put the dx dt. So they gave you x is equal to 9. That's what they're giving you here. X is 9. But then they're saying it's increasing by 3 items per year. So they're also giving you dx dt. Okay. All right. So then you plug everything into that formula and you end up getting 9. So your average yearly cost is increasing by 9 per year. In other words, that the average yearly cost of producing an X items is increasing by 9 per year. Okay. I'm not going to do that one. I'm not going to do that one. Watch the video. This one is frequently on the test. So let me just show you this one. So they're talking about a car. Here's a picture, and the car's one car's going this way, one car's going that way. And they tell you 65 kilometers per hour. Is that a rate or a value? Rate or a value?
Right.
Anyone? Yep. 45 kilometers. Is that a rate or a value? 45. Anyone? Pavani, 44 fifths. Is that a rate or a value? It's a value. There's no word per in it. It's 4/5 of a kilometer. How about 49? That one says 49 kilometers per hour. Is that a rate or a value? 49.
rate.
It is. Thank you, Alicia. It's a rate. And 2/5 is a value. And the relationship between the cars is this Pythagorean theorem, x squared plus y squared equals z squared. That's the main idea. You take the derivative with respect to t of everything, and you end up getting 2x dx dt, 2y dy dt equals 2z dz dt. Okay, remember, we have y and with dy dt. We have, we have the values and the rates for x. You know how far away the car is, that's x. We know how fast the police car is traveling, that's dx dt. X dx dt. We know how far away the y car is and how fast it's going, dy dt. We're looking for dz dt. We're looking for an answer that's a rate. How far is the distance between them? How do we get this last z, though? That's another value. Well, that's going to come from the Pythagorean theorem formula where x squared, which is actually the main idea, x squared plus y squared equals z squared. So if you know what x and y are, you can figure out what z is. So z is equal to that. Okay. Then you plug in everything you know into the equation. And a lot of people just remember this. Honestly, this is what my students do. They take the 65, they multiply it by the 4/5. They take the 49, they multiply it by 2/5, and then you divide it by the square root of the 2/5 squared. They divide it by this. Okay, and that gives them the answer. Okay, all right. That's related. All right. Let's break up into our groups and go into the mean value, finish the mean value theorem, because I don't want to work on it next time. Because it's the day before the test. I want to be free to answer any questions if I have to. So what am I looking for? I'm looking for, no, oh, this will do. I'm looking for this. So in mod 5, there's something called mean value theorem. So here's what I need for you to do if you haven't done it already. I need you to identify what A and B are. First of all, you need to know this is a quartic regression. Okay, but A and B, I'm going to move them down here. So they're mean value theorem A and B. So I moved them down. Then I'm going to open up mean value theorem. Okay. Where did A and B go? Oh, here they are. Let me move them up. You know, it might just be easier to do it this way. I'm just going to put in 0 and 20. 0 and 20. 0 and 20. Okay, so that's the average rate of change between 0 and 20 on this graph. And the average rate of change can be written if I click on line, that one, no, this one, there it is. See the orange line? That's the between 0 and 20. That's the secant line. The slope of the secant line is 50 here. Okay, so that's the first thing I need, and I have it, it's 50. All right, the next thing I need to do is turn that line on and turn that line on and find the intersections of the blue and the green line. And you find the intersections. One of them is at 7.52. It's at that. So that's one of them. So I'll copy that over here. And then the other one is this 17 point, Put that over there. And then I want to take the derivative of those two. You see what I get when I take the derivative of those? I get 50. All right. So what I need to see, I don't need to see, I can turn off this one. And all I need to see is that those are all equal to 50. The average rate of change is equal to the instantaneous rate of change at those 2 points. Okay. Now the next thing I'm going to do is I need to change this C0 to one of those two values. There's 17 point whatever. And then turn that graph on. You see how they're parallel? I need to see parallel lines. That tells me that the slope of the secant line is the same as the slope of the tangent line here at 17.48648. Okay, so I want to see this line, average rate of change. I want to see the instantaneous rate of change of any point that's relevant. And then I want to see the secant line graphed, and I want to see the tangent line graphed. I could have picked the other number too, 7 point whatever, copy, paste. See, and now I have a line here that they're parallel. Okay, if I decide to move this line, you'll see it's not parallel. The tangent line isn't parallel. Although it gets pretty close. There's another one over there where it's equal to. Okay. Any questions on that? Can I break us up into our groups now? Yes. No. All right, I'm gonna break us up into our groups. Okay. We have 4 breakout rooms. Do you know what room you're in? If you do, join it. Okay. Carlos, show group you're in.
I don't remember.
I don't remember either. Do you remember who any of your
Sebastian and Aiden.
Aiden?
Yeah.
Okay, they're room 3. So there you go. Pavani, do you remember what room you were in? Pavani, hello. Let's see, I'll find out what she was in. Bonnie was in. Oh, sure. Now she goes into. Okay, Christian, I'm gonna wander around. I see you've walked away, so that's fine. Hello.
Bye.
I closed the breakout room because none of you needed any help from me. So you're all good. All right. I'm gonna wait till everybody gets done and then I'm going to move on with some stuff. All right. Leave that. Uh, okay. So next time, we're going to both review for the test and we're going to go over inverse trig functions. And I just want to point out with inverse trig functions that that's when you put to the -1 power. So for this one right here, it's the derivative of the inverse sine of x raised to the -1 power. Okay, x raised to the -1 is just itself x to the -1. But when you take a transcendental and you write to the -1 or you write a function to the -1, that means inverse. Okay, arctangent means inverse tangent. Cosecant to the -1 means inverse cosecant. You could just write f to the -1. When you write it that way, it doesn't mean 1 over f, it means inverse. Okay? And you can evaluate functions at specific points. This guy right here is the inverse hyperbolic sine evaluated at A. Okay. All right. So what I have to do next time, or what we're going to be doing next time, and they'll be on, oh, that's what's missing from this. I knew it was missing from this. Why didn't I put it on there? All right, so I may have to add to this some things because if I go into mod 0, click on this. I have to do inverse functions, but I also have to do differentials and error. Those are not on the say it thing, so I'm gonna have to add them. But differentials are just a differential is when you take the derivative with respect to nothing. So a differential looks like it just says dy, that's a differential. Okay, we'll talk about that next time. Let me talk about the test for a second because that was here. You know that the test is going to be 15 questions, and they're going to be very similar to the quiz questions. The difference is that the questions where they say stuff, and then you're really not saying, you're just writing it down on the quiz. That's only because the computer can't grade them and it doesn't watch what you're saying. I will be watching what you're saying. Okay, so you just, the way you're going to take this test is you're going to go into mod 5 and you'll see it says test 1 and you'll click on it and it will take you to honor lock first. You'll do the honor lock things and then it will take you to and then it'll start the test. And it'll go one question at a time. But while you're in honor lock, it'll be recording you. Okay, and so when it says say something, you need to say it, and that's what you're going to be graded on. You also have the opportunity to make notes to yourself. So the answer, when you put answers in the answer spots, those are really for you. Because what I'm grading is what you say. I want you to think of this test as an interview. Okay? Have you ever been interviewed? Have you ever been on a job interview before? Anyone?
Yeah.
Yeah.
What did they do?
Oh, I don't remember actually.
But how was it? What happened at the interview? What happened?
They asked questions and I answered them.
Okay. Did you get the job?
I did.
Oh, good. So I guess when they asked you questions, you answered them in a way that they liked. Yes?
Yes.
All right. So that's what I want you to be thinking of when I'm interviewing you on this test. The questions will be there, and just think of them as like questions on an interview. And they'll be like, so what is math? And you will answer it. And as I said, the only thing you need to know is, or you think you need to remember is you have to answer it fairly well. If you want to get all the points, it's not as easy to get full credit for something because if you take too long to answer it, you'll lose points. Or if you make a mistake and don't correct it, you'll lose points. Okay. The first 3 questions are vocabulary. They're all going to be spoken. There'll be a spot for you to write things in, but they're all going to be spoken. Okay. The next 3 questions are read out loud. Those are definitely going to be spoken. And what I'd like you to do, there is a spot for you to write stuff down, but I want you to read it first because that's what I'm going to be grading you. Read it first, and then if you want to make notes, you can write them down afterwards. Okay. So you should have plenty of time to take notes when you're done the question, when you're done saying it. If you want to make notes and put stuff down, put it down because it's recording, but you don't get a copy of the recording. So you making notes is more for you. Okay. So if I take off points, you can argue with me. But you can say, I had the right answer. But anyway, then there are going to be those ones for what happened here. Okay. Those you can also say, those are probably not going to be said out loud because you just have to click on them. They're like, pick whichever ones, but you could say them too. I just don't want you to screw up the different choices. So then there's going to be the questions that you have to do, and you have to do them on Desmos. And I have to see the work, no calculators or anything like that. Again, if you were being interviewed, you wouldn't want to you wouldn't want to pull a calculator out and start typing on it. It doesn't look good. So when you do it on Desmos and show me. Okay. And just like an interview, you might still get the job if you make some mistakes here or there. So don't worry about it if it's not, I'm not grading you on your appearance or whether or not you're 100% accurate all the time, but people make mistakes and that happens. It's not a bad thing to do on an interview. Big mistakes are bad things to do on an interview, but little mistakes, no. And correcting yourself is always better. What else? Then the last questions are going to be the group work questions, which we've done. We've been doing them all along, so you kind of know what to expect. But I can tell you for this first test, there's really only going to be 3. One of them is going to be an average rate of change. One of them is going to be a limit. One of them is going to be a derivative. Okay. We don't have any more to pick from. For the midterm, we'll have more to pick from. But those are I only have 3 questions and I have 3 topics so now I know what they're going to be. Okay. I was going to go over this, but I think I'll just let you go over it. I have this advice to give you on how to take a test, but I think I'll just let you watch the video. I have some good food advice questions. But I'm just, my back is bothering me, so I think I'm just gonna let you go. Unless you guys have questions. Do you have questions? Anyone? All right, so we meet again on Thursday. Hopefully my back will be better by then. But and if you have questions about this, you're awfully quiet. You have no questions about this test? None at all? How about somebody asked me what to study? What should you study for this test? How are you going to prepare for it? Jonathan, how are you going to study for this test? What are you going to do?
I'm going to read over the speak out louds and study those.
Okay, so that's good for this. That's 1/5 of the test. What else?
I'm gonna review videos on topics that I'm not 100% sure on.
Oh, okay. What about you, Slade? What were you going to say?
I was gonna say I'm gonna look at the homeworks.
The homeworks?
Yeah.
Can we go back at my calculus 1 book?
You guys, so can I give you some advice? These are not the greatest ideas that I have heard. I mean, Jonathan's not too bad, but the tests in this course look a lot like the quizzes. The homework if you've taken the quiz, you'll notice how little the homework looks like the quiz. Did you notice that? Like the quiz asks you some questions about the homework, but really, so if you're looking over the homework, maybe just to get an idea of what's happening, but almost every single question that I asked on the quiz when it comes to the homework stuff, that's probably already on the quiz. So you're better off looking at when you go to the quiz and it says pick lines 4 and 5, there's always those other lines. Look at the other lines. See if you can figure them out. And if you can't, then look at the homework. Okay, so Jonathan's right about the first one. You can look over the say out loud questions or the class questions. Should you look over those? Then for the second group, you will look at the say out louds with the how do you say these things? So that's good. For the third group, look at the quizzes. Don't look at the homeworks, but look at the quizzes. If you have a problem, look at the homework. For the fourth group, that's the hard one. Because if you only took the quiz once, you probably only got one of the types of questions that I could ask. But on any one of those quizzes, there could have been 3 or 4 different types of questions. Okay, so it's not just enough to look at your quiz. You might want to look at somebody else's quiz. And if you're not like Garv and Rudra, who are at the same spot, you might not have anyone else's quiz to look at. So in that case,
Yes. You need
Yeah.
something?
no,
Oh, okay. Just wondering.
no.
Okay.
I just mentioned that you're in the same location because there's 2 of you in the same Zoom.
Yeah,
meeting.
yes, sir. I also sent you a message while we both are together.
I know it doesn't matter. It's fine.
Okay. Yep.
But and then the last one, you could look over the discussions. You could even just look at the example. If you don't want to look at your own, you can look at the example one. That's fine. But I'm mostly concerned about the questions that you have to do. So I think on Thursday I'll go over that. I'll try to go over samples of all the questions that were of that type 4, those 4 questions, where it's like do this and do that. Okay. But remind me to do that. Is that going to be good enough? Are you guys okay with that? Hello?
Okay. Good answer.
Okay.
Sounds good.
Because you know I actually have one of these already made. I could just give it to you, but you're so quiet. I'm reluctant to give it to you. I didn't offer it to the other class. But anyway, you'll have to convince me if you want to. But anyway, I gotta go. My back is bothering me. So, and you guys don't have any questions? I'm out of here. And you guys can head out and the live stream is done.
Feel better.
Thank you, Jonathan. Have a good day. Take care. Bye-bye.